So this was the problem on which we stopped yesterday. So we saw that the greatest common factor between 3n cubed and 4n squared was just n squared. And if we factor n squared out of 3n cubed, we're left with 3n minus. If we factor the n squared out of 4n squared, we're left with 4. Now that does help us a good bit in finding out what we need to factor out, or what the greatest common factor of the other two terms are. Because for us to be able to factor this by grouping, what's inside this parenthesis has to be the same with what we have left over inside the other, for us to be able to factor by grouping. Which tells me I want to be able to factor something out of 9n minus 12 so that I get 3n minus 4. So we can do it this way. So what do we need to divide 9 by to get 3? 3, yes? And what do we need to divide 12 by to get 4? 3, yes? So that's a way to look at it. We could also just have looked at 9n minus 12 and seen what was in common with 9 and 12. 3, we factor it out and get 3 times 3n minus 4. Questions on this here? Now we have 3n minus 4 in common in both terms, which means we can factor it out of both terms. We can divide it out of both terms. We can remove it from both spots. And if we remove it from this first expression, we factor it out of our n squared times 3n minus 4. What we're left with in this first spot is just positive n squared, or just n squared. If we factor the 3n minus 4 out of our second expression, what we're left with is positive 3. Telling us that the factored form is 3n minus 4 times n squared plus 3. 3n minus 4 is fully simplified. There's nothing in common with 3 and 4. Degree is 1, so that's as simplified as it gets. N squared plus 3, we do have a degree of 2, so there might be a chance that it does factor. But because it's a sum, we don't have a sum of perfect squares. There's no middle term, so it's definitely not going to factor by most of our methods. Telling us that 3n minus 4 times n squared plus 3 is completely factored. Simplified as it gets. Questions on this here? Let's look at the next one. I think we've got like 2 left. Now, here, again, we can group it however we want. But I normally take the first 2 terms and put them together, and take the second 2 terms and put them together. Now, 12n cubed plus 4n squared. Well, we know between n cubed and n squared, it has a greatest common factor of n squared. So we'll start here. This is cleaner. Catch. We're going to have him catch because that's going to be easier to throw to him than it is to throw around. So for the first part of this, we will have n squared. Is that getting it up?
Yeah.
Sweet. I can get it in a bit, or you can just put it on the desk. Now we need to figure out what goes into both 12 and 4. 4. Because 12 divided by 4 is 3. N cubed, if we take n squared out, we have n, 3n, plus. If I factor 4 out of 4, 1. If we factor n squared out of n squared, we also have 1. Because 4n squared, if I take the whole thing out, we're left with 1. Whenever we're factoring, it will never factor to 0, because what we're doing is dividing. And we can divide by itself. There's no way to divide a number other than 0 by something and get 0. It just does not work. So we have this here, 4n squared times 3n plus 1. Questions on this here? So 2 ways we can go about looking at the next set of terms. The first is we just look to see what's in common with both terms. And we find that greatest common factor, we factor it out. What is in common with 3n and 1? Is there anything in common with 3n and 1? Well, no. The other method that we could do and look at this is we know that whatever ever is left over after we factor out the greatest common factor has to match what? 3n plus 1, yes? Well, wait a minute. What do we have here? 3n plus 1, it is already matched to it, yes? So really what we're factoring out, we don't have to write it. We don't have to write 1. But essentially, we're just factoring 1 out of both terms, which is the same as just saying plus 3n plus 1. It's already the same. Now we do the same thing we did before. We can factor 3n plus 1 out of both terms. Now if I factor 3n plus 1 out of the first term, we do have 4n squared left over, because we take the factor 3n plus 1 away from it. Now our other expression, we're factoring 3n plus 1 out. We're removing that out, yes? So it's going to reduce to what? 1. Because we're dividing 3n plus 1 by 3n plus 1. We're dividing it by itself. Anytime we divide something by itself, it's going to simplify to 1. So no matter what we do, when we're factoring, it will not simplify to 0. The smallest it will simplify to is 1. And that's it. Questions on this here? Questions on anything we've done so far? Because even if we look at this here, 3n plus 1, 4n squared plus 1, no greatest common factor between either one, simplified as it gets. Let's look at the last one. 244az plus 56ac minus 84yz minus 21yc. These are some really big numbers, yes? Because up to this point, most of what we've been doing, it's easy to see greatest common factor. It's able to see our greatest common factor among each set of terms. Nice and easy to work with. These, it's a little bit harder. Yes? So, there's nothing saying that we can't just take a greatest common factor out to begin with. Because if there is, it might make this easier to work with. And that would be looking for a number that goes into 224, 56, 84, and 21. There are so many numbers that could possibly work for all of these here, yes? When I look for greatest common factors, I look at the smallest number. Because if something's going to work, it's got to work for all 4, yes? What is our smallest number here? 21. So whatever the greatest common factor is, if there is one between the 4 terms, cannot be bigger than 21. That's just how this is going to work, because if we said it was, if we tried, say, 24, 21 divided by 24 does not divide nicely. I can't take a nice divisor bigger than our smallest number. So best case scenario is that they're all 4 divisible by 21, that would be great. 224 divided by 21 is, okay. We know 21 doesn't work. What's another factor of 21? 7. Well, that's promising. 56 was the next number, yes? 8. 84. So what we've determined so far is that all 4 are actually divisible by 7. That's actually very helpful, because if I factor that out of all 4 terms, 21, we get 32az plus 8ac minus 12yz minus 3yc. Would we say those are nicer or more manageable numbers than what we started with? Yes. So sometimes, especially when it goes with bigger numbers, let's see if there's a greatest common factor across all of it. Even if we didn't see this, we could get there eventually. We could pick the first two, 224 and 56, find the greatest common factor across those two, factor it out. And we could get there, but 32 and 8 is a lot nicer. Because grouping these two and grouping these two is a lot nicer to work with than our original numbers. So, what terms in common with 32az and 8ac? What number will go into both 32 and 8? I think 8 is right. 32 divided by 8. So, our greatest common factor, use red, between these two here, 32 and 8, is 8. Do we have anything else in common with 32az and 8ac? A. And that's it. If we factor 8a out of 32az, 32 divided by 8 gives us 4. The a factors out completely, giving us 4z. Plus, if we factor 8 out of 8, 8 divided by 8 is 1, so it's going to simplify. If we factor a out of a, just like before, it simplifies, and that leaves us with c. So we factor 8a out of our first two terms, we're left with 8a times 4z plus c. Questions on this here? Now we need to look at our second set of two terms, yes? So we can look at greatest common factor. So what is the greatest common factor between these two terms? 3 and y, yes? If I factor 3 out of negative 12, what do we get? We get negative 4. Yes? The y factors out completely, leaving me with z, yes? I'm going to stop here for a second, because we know what's inside those parentheses has to be the same, yes? They're already different at the moment. What's the big difference between the two? One's negative and one is positive. So wait, there's an easy way to fix that, isn't it? Instead of just factoring out 3y, we could factor out what? Negative 3y. And we can make sure this works, because negative 3, if I factor it out of negative 12 divided by negative 3 is now positive 4. And we still have the z, so it's positive 4z. Okay, that matches. If I factor negative 3y out of this negative 3y, negative times a negative makes it positive. And I still have my c term, yes? Because both of the signs were opposite, factoring that negative out fixed it. Now, we do this especially if both terms are opposite the two that are inside the parenthesis. Now, that could be in this case where both inside the one parenthesis are both positive. The other two are currently both negative. Taking that negative out works. It could be inside the first parenthesis, the first term, 4z in our case is positive, the c is negative. And if we look at the other, the 4z is negative and the c is positive. Both signs are flipped. So factoring that negative out will fix that sign error. But we are now able to factor what out? 4z plus c out of both terms, yes? And if we factor it out of that first expression, what we're left with is 8a. When we factor it out of the second expression, we're left with negative 3y. Telling us that we have 7 times 4z plus c times 8a minus 3y. And that's it. Questions on any of this here? Questions on anything we've done so far? And that is actually it. Okay. 3. So this is actually all that I was going to cover with our factoring, at least here over factoring before we start the next chapter. We're not going to start the next chapter next week. We are going to test over factoring. I do this, 1, make sure we are understanding, and 2, it is a nice grade kind of get a test in, 200 points in. Over this here, you do well, it's going to help you, especially down the line. We actually have some points in. Good way to start the year. So Monday is going to be review day / makeup day. So again, I'd work on those assignments, get them done. You'll have time on Monday to work on the review too. Tuesday, we're going to go over it. So sorry, Tuesday we'll have the makeup day review. Wednesday we'll go over it, and Thursday, Friday will be the test. Yep. Yep. So we only have 3 assignments attached to this here. If you have not done the comments over the videos from last week, make sure to get those done, turned into Google Classroom. Just submit that quiz assignment. And that's the only assignments we have.